Good morning. We are here to do a video walkthrough of Algebra 2, LT number 1, practice quiz number 2, investigating functions. Let's start at the top. Standard 1.1, identify a function from multiple representations. We're looking for a function. Function means that each input has one consistent output. So if we look at this first one, inputs are x, outputs are h of x. I see an input of 5, output of 1, input of 0, output of -2, input of 5, output of 0. And look what we've got here. I see an input of 5, output of 1, same input, different output. Same input, different outputs means not a function. Second one, inputs on the x-axis, outputs along the y-axis. Do we see any x values for which there are two y values? Right there. So 86 has two y values, not a function. Right. We come over here, we check the graph. Are there any of x values for which there are two y values? Some of you remember the vertical line test that checks to see, are there two y values for any one x value? No. Along the way, every x value has only one y value, so it is a function. All right, let's go down. Let's look at domain and range. Now, when we're looking at a table, like this, our domain is the individual elements. Typically, we try to write them smallest to greatest, but it's not the end of the world if we don't. So we have -6, 0, 5. Do I have to write 5 twice? No. I just see that 5 shows up. Wait, this isn't a function. Does that matter? No. Non-functions still have domain and range. For the range, again, domain are the x values, the inputs, range, the y values, the h of x, the outputs. So -2, 0, 1, 3. We just write the values we see. It's not -2, 2, 3, all numbers included, because those numbers aren't in there. It's just specific values. Same applies for the scatter plot right here. What's our domain? Our domain are whatever x values are included. -2, -1, 0, 1, and 2. Now this one is a function. Does that change it? No. Same idea. The range goes from -2, -1, 0, and 1. 1. There are two that have a y value of 1. We just write 1 once. Let's go down to this one. Our domain and range. I see that there's left we read domain left to right. Our furthest left value, our most negative, is from -3. Going to the right, I see an arrow, which means it goes to infinity. Now it's totally fine if you want to write this infinity is not included. Because this is a filled in dot, we are inclusive of -3. Now you can write it in interval notation, or you could write it in inequality notation. Just remember, parentheses, x is less than, bracket, x is greater than or equal to -3. For the range, the furthest down it goes, there's an arrow, so the furthest down is -infinity, and it rises all the way to 3. Inclusive, exclusive. How would that be written with inequalities? -infinity is less than y, which is less than or equal to 3. All right, let's check this one. Our equation. These ones can be tricky, but I want you to think about, if I look at this equation, what would break it? If I put it in my calculator, when would I get an error? I would get an error if this x minus 4 was less than 0. So the value inside the square root needs to be at least 0. So that means x has to be bigger than what? It must be at least 4. If I put in, say, if I put in 3, 3 minus 4 is -1. What's the square root of -1? Not a real number. 4 minus 4, though, is 0. What's the square root of 0? 0. So our domain goes from 4. Is there any limit to how big a number I can take a square root? No. So it goes to infinity. You could also write that like this, just x is greater than or equal to 4. You could write it like that if you wanted to. For the range, what kind of numbers do square roots output? They always output positive numbers, always positive. Now there's nothing affecting the square root. There's no plus, minus, multiply. There's nothing there. So that means we're just thinking about a square root all the time. The square root's only going to output positive numbers. So that means 0 to infinity. You could also write that as y is greater than or equal to 0 like that. And that works too. All right, let's move on to the back side. So determine each value if g of x equals 2 times x plus 4 squared and h of x equals 3x minus 1. So what is g of negative 9? Well, that means we're going to take that negative 9 and we're going to substitute it in for x equals 2, negative 9 plus 4 squared. All I did was take the negative 9 and I substituted it in for x. It is my new input. So let's evaluate this. Negative 9 plus 4 is negative 5. Negative 5 squared is 25, which equals 50. All right, next step. What is x if h of x equals negative 50? Notice, h of x, h of x. That means negative 50 is our output. We are solving for x. If it says what is x, that means we're solving for x. So let's solve this. 3x minus 1, add 1 to both sides. Negative 49 equals 3x, divided by 3, divided by 3. So x equals negative 49 thirds. And we can just leave that as a fraction. If you want to write it as a decimal, that's fine too. Fractions are more precise. What is g of h of 0? So what we want to do here, this is called the composite function. We want to work inside out. So our first step is let's just find h of 0, because the output of h of 0 will become the new input like we did up here for g. So what is h of 0? So instead of 3x minus 1, we're going to do 3 times 0 minus 1, which is just negative 1. So h of 0 is negative 1. That now becomes my new input for g. So 2 times negative 1 plus 4 squared. So that's 2 times 3 squared, 2 times 9. So that means g of h of 0 equals 18. Why is it g of negative 1 and g of h of 0? Because h of 0 equals negative 1. Negative 1 and h of 0 are the same thing. All right, let's look at this one. G of h of x. Okay, so in this version, you got to be careful. All right, we're going to use h of x as the input into g. So remember that g of x is 2 times x plus 4 squared. What I'm going to do is I'm going to take h of x and replace x with h of x. So that means g of h of x equals 2. Instead of x, I'm going to replace it with h of x. 3x minus 1 plus 4 squared. Almost forgot. Plus 4 there. All right. Simplify. 2, 3x plus 3 squared. And let's expand it out so we can combine. All right. So 3x plus 3 squared. To do that, you can either do an area model if you'd like. 3x plus 3, 3x plus 3, 9x squared, 9x, 9x, 9. A lot of 9s there. So it's 2 times 9x squared plus 18x plus 9. Simplifies out to 18x squared plus 36x plus 18. That is g of h of x. If I use an input of h of x, 3x minus 1, and I put that in for g, that is what I will get out. All right, let's move on to 1.4. Sketch a graph that satisfies the following. Is a function, has 3 x-intercepts. The domain goes from negative infinity to infinity. The range is negative 3 to 5 inclusive. Okay, let's break this down one at a time. So is a function, that means it can't be swirling around. It can't have we can't have two y values for one x value. Domain, negative infinity to infinity means we're going to end with arrows pointing both directions. We have to be careful with those arrows though, because if the range is negative 3 to 5, well, we can't go beyond negative 3 and 5. Those are hard stops. So I'm going to put those in here. 2, 3, negative 3, 1, 2, 3, 4, 5. It's okay if it's a little messy. This whole graph is a little messy. It's just about understanding what is the criteria here. So let's think about this. At some point, we need to hit negative 3, and we need to hit 5 with 3 x-intercepts. So I'm going to start here. I'm going to start at 1 x-intercept is right here. I'm going to put 1 right here and 1 right here. Now, how do I need to go? How high? Well, I need to touch -3, but I need to remember that I'm going to go touch -3. I'm going to go up, but it needs to go forever to the negative direction. So I'm going to go horizontally straight out to the left. That way the domain goes all the way to -infinity. Now on this side, I'm going to come back up. I'm going to go through 5, getting my range there. I'm going to come back down here. Not a vertical line, because a vertical line wouldn't be a function. Do I need to go all the way to -3? No, I already got it included. So I can come back up, get my third x-intercept, and then go straight out. Going to positive infinity, negative infinity, 1, 2, 3 x-intercepts, range of -3 to 5. Beautiful. Is it a function? Yes. 3 x-intercepts? Yes. Domain, -infinity to infinity? Yes. Range, -3 to 5, limited? Check. That means we're all good. All right. Hope this was helpful. Good luck with your LT1 quiz.